Hello, myself Dharma. In this presentation, we will be discussing about round-robin scheduling algorithm. Before going into the theory part, let us consider a real-life example of round-robin scheduling algorithm. What we are seeing here, a Pani Puri seller. Suppose he got 3 customers here. This guy came first, this guy came second, and this guy came third. Between 1 second. Alright, the guy who came first wanted to buy 5 puris, the guy who came second wanted to buy 3, and the guy who came last wanted to buy only 1. If we follow first come first serve approach, so we have to serve this guy first, right? And let us assume the time taken to serve 1 puri is 1 second. So the second guy has to wait 5 seconds, and the third guy has to wait 8 seconds. But in real Pani Puri shops, this won't be happening at all. If this actually happen, their expressions won't be like this. They will be like this. And the Pani Puri seller won't want that. So what will happen? In round robin scheduling algorithm, it is similar to first come first serve approach only, but the customers will be served in a circular manner. That is, this guy wanted 5, right? And this middle guy wanted 3, and last guy wanted 1. In each cycle, the Pani Puri guy can only serve 1, right? He is a human being. He has some limits. Initially in the first round, he will be served 1 and he will be left with 4. He will be served 1, he will be left with 2, and he will be served his 1, and he is going to go after spending only 2 seconds of waiting time. We are going to ignore switching process here. It is a simple case. He waits for 2 seconds. So he won't be looking like this actually. He will be quite happy like this. Since his quota gets completed, he will be leaving the shop, and this guy will be served his third second. Let's keep our count. And this guy will be served his second, and he will be left with 1. The time will be 4 seconds, and this guy will be served his third. He will be left with 2. Time will be 5 seconds, and this guy will be served his last, and he will be leaving at 6th second. Even though it has its disadvantages, that is, he only waits for only 5 seconds here, but he has to wait for 6 seconds here. But we are happy enough that our guy who came last and came only to buy 1 puri leaves as early as possible. That is only 2 seconds, not 8 seconds. So this is a success, and this guy may not be as happy as that guy. So let us think that those two guys are best friends, and he is happy for his friend, and he leaves the shop like this. And we have our last guy left, and he will be served his 2, and that waiting time will be 8, and he leaves happy because he is getting served 1 each in each cycle, right? Okay, now coming to theory, what actually is a round robin scheduling algorithm? It is a process scheduling algorithm. There are 2 types of process scheduling algorithms, right? Preemptive and non-preemptive. This is a non-preemptive process. What is meant by non-preemptive process? The process can switch between processes. I'm sorry, this algorithm has the power to switch processes in between before the current running process is completely executed. We will face some interrupts in this process. When an interrupt is faced by operating system, the control of CPU will be moving to another process. After this process gets executed, the control is given back to the original process, and our original process completes. This is known as preemptive process. And Our round robin scheduling algorithm is a practical case, practical. Why I'm calling is practical? Because the shortest time first serve approach is not practically possible, because it is not possible to know the birth cycle of a process before it arrives. We only know the birth cycle of a process whenever it completely executes. Then we can calculate the time it has consumed, right? So this process is a practical case, and this is used for scheduling time sharing systems, right? Okay, we will hear a word called time quantum. Time quantum is nothing but, considering the above Pani Puri example, 1 second, which is the time taken for each step in a particular cycle. It will be ranging between 10 to 100 milliseconds in practical cases. What happens if it is greater than 100? Then the waiting time will be more. The waiting time will be more, right? Then there is no actual difference between first come first serve and round robin. And what happens if it is less than 10? Then the context switchings will be more. What happens if they are more? There is a time for each context switching, and it will be multiplied with number of switches occurred, and the time wastes will be more. We won't need that, right? We don't want to make those guys look angry like this. Okay. Here the CPU scheduler allocates a time quantum for each process, as we have discussed above. Okay, how to visualize it? We will visualize it using a ready queue. Also, it is called a priority queue. The process which came first, let's say P1, is placed at the head end, and the process P5 came last. Process P2 came after P1, P3, then P4, and P5 will be placed at the tail end of the queue. This arrow is nothing but the process scheduler or CPU scheduler for our convenience. There are two possible cases. What if the birth cycle is less than 1 time quantum, and what if that time quantum is birth cycle is greater than 1 time quantum? First of all, let us discuss the second case, because we have to traverse the whole queue, right? For our explaining convenience, let us assume process 1 has 7 milliseconds as its birth cycle, and the process scheduler has time quantum of 5 milliseconds. So in first cycle, this process will get executed, and 2 milliseconds will be remain. What happens after executing this process? We will be setting a timer before the starting of the process, and the time which is set is equal to the time quantum of each process. Time quantum only. When the timer goes off, our operating system will be faced an interrupt. What happens if it is interrupted? Context switching happens. What is context switching? The CPU will be allocated, assigned to next process by CPU scheduler, and then the same thing happens. For our convenience, let us assume the process P2 has also birth cycle more than 1 time quantum, also process 3, also process 4, also process 5. What happens if it reaches the tail? As the name suggests, it is called round robin scheduling algorithm. It goes again to first process and checks the remaining time. What is the remaining time here? 2 milliseconds, right? Yes, 2 milliseconds. We have to see the first case then. What happens if it is less than one time quantum? After executing the process, which is only 2 seconds, we won't be needing 5. After executing first process completely, the CPU scheduler will proceed to next process, and it won't be coming to P1 again. For our convenience, let us assume we will be moving this head forward, or we will be removing this process P1 from the queue, and process P2 executes. Let us assume the process P2 has also completed, and process P3 executes. Let us assume the process P3 has still some time left. Then process P4 executes. Let us assume it still has some time left. Then process P5 executes. Let us assume it completes. Then our process will come to P3. Think it's completed its bird cycles. Then P4. Then P4 also completes. Have you understood? This is the process, and this is the explanation of round robin scheduling algorithm in brief. Thank you for listening to the presentation. Goodbye.